Find somewhere comfortable tonight, somewhere your body can be heavy. You do not need to follow any of this closely. You do not need to remember a word of it. There is nothing here that requires your concentration, nothing that asks anything of you at all. Just let the words come in quietly, the way water moves around a stone, gently, without effort, without you having to do a thing. If you have been carrying something today, you can set it down now. Whatever it was, the worry, the unfinished thought, the thing you keep turning over in your mind when you should be sleeping, you can let it rest beside you just for a while. It will still be there in the morning if you need it. Tonight, you do not need it. Tonight, we are going somewhere else entirely. We are going down. Down past the place where the light fades, down past the last warm currents, past the edge of everything familiar, into one of the most ancient and undisturbed places on this earth. A place so vast, so patient, so deeply, profoundly quiet that it makes the night feel shallow by comparison. We are going to the deep ocean, not to study it, not to conquer it. Just to visit, the way you might sit beside a river for no particular reason and find, after a while, that something in you has settled. There is no rush tonight. We have time, all the time you need, and the ocean, as you will find, has been waiting for exactly this long. It has been waiting, in its slow and ancient way, since before there were words for waiting. So breathe, let your shoulders drop, let the weight of the day begin, slowly, to loosen. We are going down together. There is something that happens to light when it enters the sea. At the surface, on a calm day, sunlight scatters and dances. It breaks apart into shifting patterns on the shallow floor of a rock pool. It reaches down through the first bright meters and turns the water every shade of blue and green that a painter could wish for. For a while, it seems like the light will go on forever, following you down, faithful and clear. But it doesn't. At around 200 meters below the surface, which is roughly the height of a 60-story building, the light gives out. Not all at once. It fades the way a room fades when someone turns a dimmer switch very, very slowly. First the reds disappear, then the oranges, then yellow, then the last of the green dissolves into blue, and then the blue too becomes thin and pale, and then it is simply gone. And what remains below is something that has no word quite adequate to it. Not darkness exactly. Not the darkness of a room with the curtains drawn, or the darkness behind your eyelids. Something older than that. A darkness that has never known light. A darkness that is so complete, so total, so absolute, that it has its own kind of presence, its own kind of weight. Below 200 meters is where the deep ocean begins. And the deep ocean covers most of this planet. That is worth sitting with for a moment. When we say the Earth is a blue planet, when we see it from space as that pale, luminous sphere hung in darkness, nearly 3/4 of what we are seeing is ocean. And of that ocean, the vast, overwhelming majority, something close to 90% of it, is deep. Beyond the light in that ancient, patient dark. Which means that the largest habitat on Earth, by far, is one we have barely seen. More people have traveled into space than have descended to the deepest parts of the ocean. More of the moon's surface has been mapped in detail than the floor of the sea. There are mountain ranges down there longer than the Himalayas and taller than the Alps, ranges that run for 45,000 miles around the globe, and for most of human history, we did not know they existed. We live on the surface of a world whose depths remain, in most respects, unknown. There is something quietly wonderful in that, in the fact that mystery is not finished. That beneath our feet, beneath the creaking and busy surface of things, the earth still holds its secrets gently, in the cold and the dark and the slow, unhurried deep. Let that settle. The story of how humans began to reach into that darkness is, in its own way, a story about courage and curiosity and the particular kind of patience that science requires. For most of history, the deep ocean was thought to be empty, lifeless. A vast, cold void beneath the waves, too dark and too crushed to support anything at all. The idea had a certain logic to it. Nothing that we knew could survive down there. And so, perhaps, nothing did. But there were always those who wondered. In the middle of the 19th century, a Scottish naturalist named Charles Wyville Thomson began to think that the deep sea might be stranger and richer than anyone had supposed. He was the kind of man who looked at an unanswered question, the way other people look at a locked door, not with frustration, but with quiet, steady interest. He spent years gathering evidence, gathering support, and eventually gathered something more substantial than either of those things. He gathered a ship. In December of 1872, the HMS Challenger sailed out of Portsmouth Harbour and into history. She was a converted naval vessel, a corvette, her guns removed to make room for scientific equipment. Trawling nets and sounding lines and water sampling bottles and chemical apparatus, the tools of a new kind of inquiry filled the spaces where cannons had once sat. She carried a crew of 243 men, a team of civilian scientists, and a mission so broad and ambitious it would take years to complete. The Challenger expedition, as it came to be known, spent nearly 4 years crossing and recrossing the world's oceans. The scientists on board let down sounding lines to measure the depth of the water beneath them. They lowered dredges to scrape material from the seafloor and brought it back up. They took temperature measurements at different depths. They collected thousands upon thousands of specimens. And what they found when they hauled their nets back up from the deep changed everything. The seafloor was not empty. It was not a desert. It was not a void. It was alive. Teeming, in fact, with creatures unlike anything that had been seen before. Strange, delicate, otherworldly forms that had spent their entire lives in the cold and the dark, far from any sunlight, far from any shore. By the time the expedition was over and the specimens catalogued and the findings assembled, the scientists had described more than 4,700 new species. 4,700. It took decades to publish all the results, 50 volumes in the end. Thomson himself did not live to see the publication completed. He died in 1882, before the last volumes were finished. But the work was carried on by John Murray, who oversaw the remaining reports with the same quiet patience that the deep ocean itself seems to embody. The Challenger expedition gave us something that no amount of surface observation could have provided. It gave us the first glimpse of what lay beneath. It showed us that the darkness was not empty. That down there, in the cold and the pressure and the perpetual night, life had found a way. It had not merely survived, it had flourished. Breathe. The next chapter in the story of the deep ocean took place from the side of a boat off the coast of Bermuda in the 1930s. It involved a steel sphere, a length of cable, and a naturalist named William Beebe who looked at the ocean the way a child looks at a wrapped present, with a kind of irrepressible and slightly impatient wonder. Beebe was already a celebrated naturalist when he first began to think seriously about descending into the deep sea. He had written popular books about birds and wildlife, and he had an extraordinary gift for description, for making the natural world vivid and immediate and intimate to people who would never see it for themselves. But he wanted to do something that no one had ever done. He wanted to go down. To go actually, physically, bodily down into the darkness. To see the deep ocean not through the contents of a trawl net, but through his own eyes. His collaborator in this endeavor was an engineer named Otis Barton, who had designed the vessel they would use. Not a submarine. A sphere. A hollow steel ball, roughly 1.5 meters in diameter, with walls nearly 5 centimeters thick and 3 small windows of fused quartz set into the front. A hatch, bolted shut from the outside once the occupants had squeezed inside. And a single steel cable connecting it to the ship above. They called it the bathysphere, from the Greek for deep and sphere. Simple as that. The conditions inside were, by any ordinary standard, deeply uncomfortable. The two men had to fold themselves into a space barely large enough to sit upright. There was equipment crowding them from all sides, oxygen tanks and humidity absorbers and communication lines. And outside the thin shell of steel, the pressure of the water would increase with every meter they descended, pressing in from all directions with a force that would have been, without those walls, instantly lethal. On June 6, 1930, the bathysphere was lowered into the water off Nonsuch Island, Bermuda, for the first of what would become a series of ever deeper dives. Beebe pressed his face to the quartz window and watched the light change. He later wrote about it with the kind of wondering precision that makes science feel like poetry. He described how the blue deepened as they descended, passing through shades he said could not be painted and barely be named. He described the creatures that drifted past the window, jellyfish glowing with their own cold light, things that had no names yet, shapes and forms that had never been witnessed before by human eyes. He described the feeling of the darkness closing in, not as something threatening, but as something vast and patient and, in its own way, beautiful. In 1934, on a dive off Bermuda, Beebe and Barton descended to a depth of 923 meters, 3,028 feet. It was the deepest any human being had ever gone. It would remain the record for 15 years. When they surfaced and the hatch was opened, Beebe reportedly said he felt he had visited a world that no human being might ever see again. He was wrong about that. Others would go deeper. But he was right about the world. There was a world down there, patient and dark, and it had been waiting. You may have drifted. That is perfectly fine. In the western Pacific Ocean, east of the Mariana Islands, there is a scar in the floor of the sea. It runs for roughly 2,400 kilometers in a long, curving crescent. Like a scratch left by some enormous and unhurried hand, it was formed over tens of millions of years by the slow collision of tectonic plates, one plate sliding beneath the other in a process so gradual that even a human lifetime is too brief to register it. The Pacific Plate, moving westward, slides beneath the Mariana Plate, and as it does, it pulls the seafloor down into a trench that is, at its deepest point, the deepest place on Earth. The Mariana Trench. Its deepest point is called the Challenger Deep, named in honor of that Victorian ship and its years of patient inquiry. Consider that for a moment, gently. If you took Mount Everest, the highest point on the surface of the Earth, and placed it at the bottom of the Challenger Deep, its summit would still be more than 2 kilometers beneath the surface of the ocean. The peak of the tallest mountain we know, submerged and invisible, more than 1.5 miles underwater. The pressure at the bottom of the Challenger Deep is difficult to describe in terms that feel real, because nothing in ordinary experience compares to it. At sea level, the atmosphere presses on every square inch of your body with a force of about 14.5 pounds. At the bottom of the Mariana Trench, that figure is more than 1,000 times greater. Something in the region of 8 tons pressing on every single square inch, every finger, every inch of skin, every surface. The weight of a full-grown elephant balanced on the tip of your little finger. That weight simultaneously everywhere. An iron ball dropped from the surface of the ocean above the Challenger, Deep would take roughly 1 hour to reach the bottom, 1 hour of falling through cold, still, lightless water, sinking through darkness the way a thought sinks when you are almost asleep. Slowly. Without a rival. For many decades, the Challenger Deep was something that existed only in the measurements of instruments, a depth recorded in numbers, known but not witnessed. The numbers were extraordinary. But numbers are not the same as seeing. Then, on the 23rd of January 1960, 2 men prepared to see for themselves. Jacques Piccard was Swiss. Don Walsh was a lieutenant in the United States Navy. The vessel they would use was called the Trieste, a bathyscaphe more sophisticated than Beebe's tethered spear, capable of controlling its own ascent and descent. It worked on a principle of buoyancy. Gasoline in a large float above provided buoyancy, and iron ballast weights could be dropped to control the rate of ascent. It was, in its way, elegant. A thing designed for one purpose, and designed well. They descended for nearly 5 hours. The water outside the viewports changed from blue to black to a darkness beyond black, a darkness that had no color at all because color requires light and there was none. The instruments ticked and the hull creaked and the temperature dropped and the pressure climbed and the 2 men sat in their cramped capsule and went deeper than any human beings had ever gone. At around 9,000 meters, one of the outer observation windows cracked. The Trieste shuddered. Walsh and Piccard looked at each other in the confined space. The crack held. They continued downward. At 10,915 meters, the Trieste touched the bottom. A small cloud of sediment rose from the floor, drifted in the beam of their lights, and slowly settled again. Piccard and Walsh looked through the viewport at the bottom of the world. And then Piccard saw something that, in many ways, changed everything. Moving along the seafloor, disturbed by the arrival of the Trieste but unhurried, was a flatfish, or something that looked very much like a flatfish. A creature with eyes and fins and the unmistakable shape of a living animal, moving at the bottom of the deepest point on Earth in pressure that should have been impossible to survive. The idea that the deep trenches might be too hostile for any complex life had not quite died out even in 1960. There were still those who doubted. But here, at the very bottom of the planet, in the cold and the crushing and the absolute dark, a fish was going about its business. Unhurried. Unconcerned. Life, it turned out, had settled far more deeply into the earth than anyone had imagined. Walsh and Piccard spent around 20 minutes on the bottom. Then they released the iron ballast, and the Trieste began the long, slow ascent back toward the light. There is something in that image that I find endlessly comforting. The slow ascent. The patience of it. Let that settle. We have established by now that the deep ocean is dark. But here is something that is worth sitting with very quietly, because it is one of those facts that, once you know it, changes the way you think about darkness itself. The deep ocean is not entirely dark. Not because of sunlight, which, as we have said, does not reach those depths. Not because of any light from the surface at all. But because the creatures that live there, over hundreds of millions of years of evolution, have learned to make their own. Bioluminescence. The production of light by living things. It is not rare in the deep ocean. It is, in fact, almost universal. Scientists estimate that somewhere between 76 and 80% of all deep-sea creatures produce bioluminescence in some form. Think about that. More than 3 in 4 animals at those depths carry their own light with them. A cold, quiet, living glow produced not by heat or flame, but by chemistry, by the patient interaction of molecules inside living tissue. The light they produce is most commonly blue or blue-green, and there is a reason for this. Blue-green light travels furthest in seawater. It is the wavelength that the deep ocean transmits most willingly, so creatures that have evolved to communicate with light, or to hunt with light, or to hide with light, have largely settled on this frequency, this particular shade of cold and luminous blue that exists nowhere else quite the same way. Different creatures use their bioluminescence for different purposes. Some use it to hunt. The anglerfish, which you may have encountered in pictures or in nature documentaries, hangs a bioluminescent lure from a modified spine that grows from its forehead. This lure glows softly in the darkness, moving gently as the fish drifts, looking to any smaller creature in the vicinity like a tiny, inviting light. And when the smaller creature approaches, drawn by curiosity or hunger, the anglerfish's enormous jaws, lined with long, inward-curved teeth, close around it. The anglerfish does not chase its prey. It barely moves at all. It simply waits, with its light. Some use it to evade predators. Certain squid, when threatened, squirt not ink, but bioluminescent fluid, a cloud of cold light that distracts and confuses whatever is pursuing them while they slip away into the dark. Some use it as camouflage. From below, any object against the faint background light filtering down from above would appear as a dark shadow. By matching the faint light above them with their own glow, these animals erase their own silhouettes. They become invisible to anything looking up from below them. Invisible by making light. There is something quietly beautiful in that. And some use bioluminescence to communicate. Deep-sea creatures that need to find mates in the vast, dark, featureless expanse of the midnight ocean have evolved patterns of light unique to their species, signals as specific and as personal as a fingerprint. In the darkness, they call to one another in light. There is a creature called the firefly squid that lives not in the deepest ocean but in the relatively shallow seas off Japan, and which produces one of the most extraordinary light displays of any animal on Earth. In spring, millions of these squid rise toward the surface at night to spawn, and the bays where they gather glow with their collective light. A soft, shifting, pulsing blue, like the sea itself has begun to dream, but understanding the chemistry does not diminish the wonder of it. It simply adds another layer. The deep ocean glows with life, quietly, in the dark. With its own soft, ancient, unhurried light, we continue softly. In the spring of 1977, a team of ocean scientists were exploring the floor of the Pacific Ocean near the Galapagos Islands. They were using a deep-sea submersible called Alvin, a workhorse of deep ocean research that had already been doing remarkable work for more than a decade. They were investigating an area of the ocean floor where the tectonic plates were slowly pulling apart, and where geologists had predicted, based on temperature readings, that something interesting might be happening with the water. What they found was interesting in a way that exceeded anything anyone had predicted. On the seafloor, at a depth of around 2.5 kilometers, there were cracks in the volcanic rock. From these cracks, hot water was rising, shimmering with heat in the beam of Alvin's lights. The water came up laden with minerals dissolved from deep in the earth, and where it met the cold seawater, it precipitated those minerals out, building chimneys and columns of dark, chalky rock around the fissures. Some of these chimneys would eventually grow to the height of a 10-story building. These were hydrothermal vents. Hot springs on the seafloor. This alone would have been remarkable. But what the scientists aboard Alvin saw as they approached was something that stopped them, something that should not have been there, according to everything they understood about how life worked. There were animals. Everywhere. In extraordinary abundance. Clusters of clams the size of dinner plates, mussels in dense beds, long, pale crabs picking their way over the rock. And strangest of all, rising in thick, swaying clusters from the crevices around the vents, Tube worms, red-tipped, white-bodied tube worms, some of them more than 2 meters long, the color of deep lipstick at the top, waving gently in the warm current rising from the earth below. Like flowers in an alien garden. Like nothing that had been seen before. The scientists were so astonished that the pilot of Alvin reportedly said something to the effect of, "There isn't supposed to be anything alive down here." And yet, the question immediately arose, what were these creatures eating? There was no sunlight here to drive photosynthesis, no plants, no surface-derived food supply in quantities that could support this kind of density, this abundance of life. The answer, when it was found, required a fundamental revision of one of the most basic assumptions in biology. Life, it had always been assumed, ultimately depends on the sun. The sun's energy drives photosynthesis in plants and algae, which are eaten by herbivores, which are eaten by carnivores, and so on, up and down every food chain on the planet. Take away the sun, and the foundation of the food web collapses. This was not a hypothesis, it was a principle, a given. But here, on the floor of the ocean, in total darkness, far beyond any reach of sunlight, there was a thriving community of living things. And the foundation of their food web was not sunlight. It was chemistry. Bacteria and archaea living in and around the vents were able to extract energy from the chemical compounds in the vent fluid, particularly hydrogen sulfide, a gas that smells of rotten eggs at concentrations detectable to humans, but which to these microbes represents something more like dinner. Through a process called chemosynthesis, these microbes converted chemical energy into organic matter, just as plants convert light energy into organic matter. They became the foundation of a food web unlike anything elsewhere on Earth. The tube worms, it turned out, had no digestive systems in the adult stage at all. Their bodies were filled with a specialized organ called a trophosome, packed with billions of chemosynthetic bacteria. The worm and the bacterium had struck a deal, shelter and chemical access in exchange for nutrition, a partnership so intimate and so ancient that neither party could survive without the other. Life, it turned out, did not need the sun. It needed energy, any energy. And the earth, in its slow and volcanic patience, was providing energy of its own. The discovery of hydrothermal vent ecosystems in 1977 was not just a biological surprise, it was a philosophical one. If life could flourish here in conditions that had seemed to rule out life entirely, then the boundaries of the possible were wider than anyone had supposed. If life did not require sunlight, did not require warmth, did not require the particular conditions we had assumed to be necessary, then where else might life exist? All from a crack in the floor of the Pacific Ocean, discovered more or less by accident in the spring of 1977. Between the sunlit surface and the deep ocean floor, there is a passage, a transition. A long, slow, dim corridor through which things descend. Marine biologists call the zone between 1,000 and 4,000 meters the bathypelagic zone. The midnight zone. No light reaches here at all, not even the faint blue traces that linger in the twilight zone above it. The temperature hovers at around 2 to 3 degrees Celsius. The pressure, depending on depth, is between 100 and 400 times that at the surface. And yet this zone is far from empty. There are fish here with enormous eyes, evolved not to see in darkness, since there is no light to see by, but to detect the faint bioluminescence of other creatures. There are fish with no eyes at all, their visual organs having been abandoned over millions of years in favor of other senses. There are creatures with bodies so transparent you can see their organs through their skin, a kind of invisibility achieved not by camouflage, but by the absence of anything to reflect the light that never comes. There is a fish called the barrel-eye, or spookfish, that has transparent, barrel-shaped eyes mounted on top of its head rather than on the sides, eyes that glow green and can rotate to look upward, forward, and at various angles. It uses these extraordinary eyes to detect the silhouettes of prey above it, outlined against whatever faint light filters down from far above. It is a quiet and strange-looking creature, hovering in the dark with its glowing green eyes pointed upward, patient as a thought you haven't quite finished thinking. Through all of this, through the whole vast dark column of water from the surface to the floor, there falls continuously, without stopping, something that oceanographers call marine snow. It is not snow in any ordinary sense. There are no crystals, no cold white flakes. Marine snow is the collective name for all the organic matter that drifts down from the surface waters above, where life is abundant and photosynthesis is active and things are being born and dying and shedding and defecating and decomposing at a constant rate. The dead bodies of plankton, the shed skins of crustaceans, the feces of fish, the mucus feeding nets of tiny animals, the clumped remains of algal blooms, all of this drifts downward through the water column, slowly, almost imperceptibly, like the settling of fine dust in a library where no one has opened a window in a long time. It takes weeks, sometimes months, for a single flake of marine snow to sink from the surface to the abyssal plain far below. And as it falls, it is intercepted, consumed, broken down, and transformed at each depth by whatever creatures live there. The bathypelagic and abyssal communities are, in a very real sense, supported by the rain from above, sustained by the slow and continuous fall of matter from a world they will never see, a world of light and warmth and seasonal change that is as remote from them as the surface of another planet. There is something I find deeply peaceful in this, in the image of marine snow, in the slow, patient fall of matter through cold, dark water. In the thought that even here, in the deepest reaches of the midnight zone, nothing is wasted. Everything that falls from the surface eventually contributes to something below. Everything settles eventually. Whole, everything finds its place. Just the sound of the words. There are creatures in the deep ocean that live at a pace so different from our own that time itself seems to operate differently around them. The orange ruffy is a deep-sea fish found in the depths of the southern and eastern Atlantic, the Indo-Pacific, and the waters around New Zealand and Australia. It is a stocky, bright orange fish when seen in shallower water, though at the depths it inhabits, its color makes it effectively invisible. It grows slowly. It reproduces slowly, and it lives, by the standards of fish, for an extraordinary length of time. The orange ruffy can live for more than 100 years. A fish caught today might have been born in the early 1920s. It might have been alive when your grandparents were young. It has spent a century drifting through cold, dark water, eating and growing and slowly aging in the patient dark. This longevity is not unique among deep-sea creatures. The Greenland shark, which inhabits the cold, deep waters of the North Atlantic and Arctic Oceans, may live for 500 years or more. The oldest individual ever studied was estimated to be around 407 years old, meaning it was born, as nearly as scientists can calculate, sometime in the early 1600s. It was alive when Shakespeare was still writing. It was alive during the first tentative European explorations of the Americas. It has been alive, moving through cold water, eating and breathing and continuing ever since. There is something quietly astonishing about the idea of a creature that ancient still existing somewhere beneath the ocean, still moving slowly through the dark. Still here. Slow metabolisms, cold temperatures, and the stability of the deep ocean environment contribute to these extraordinary lifespans. Where the surface world cycles through seasons and upheavals and temperature swings and the rapid churning of generation after generation, the deep is constant, patient, unhurried, and the creatures that live there reflect that unhurried quality in the length and slowness of their lives. There is no rush, The story of how we came to understand the shape of the deep ocean floor involves, at its center, a woman whose name was not always given the credit it deserved. Her name was Marie Tharp. She was born in 1920 in Ypsilanti, Michigan. She showed early aptitude for mathematics and science and earned a degree in geology at a time when geology, like most sciences, was largely a male domain. She worked as a research assistant at the Lamont Geological Observatory at Columbia University, where she met a geophysicist named Bruce Heezen, who would become her long-term research partner. It was not, in those days, a relationship between equals in terms of professional recognition. Tharp did much of the detailed analytical and cartographic work. Heezen's name often appeared first, or alone. But the work Tharp did was transformative. Using records collected by research ships that dragged sounding lines across the Atlantic Ocean, Tharp began, in the early 1950s, to plot the shape of the ocean floor. This was painstaking work. The data points were widely spaced, the measurements imprecise by modern standards, and the task of interpolating between them to build a coherent picture required not just mathematical skill, but a kind of spatial imagination and geological intuition that not everyone possessed. As she plotted the Atlantic data, something emerged that made her stop. Running down the center of the Atlantic Ocean, along what would later be called the Mid-Atlantic Ridge, there appeared to be a valley. A rift. A long, continuous feature running north to south, cutting into the highest point of the ridge, suggesting that the seafloor here was not solid and immovable, but was being pulled apart. When she showed this to Heezen, his initial response was reportedly dismissive. He is said to have called it girl talk. The idea that the seafloor was spreading, that the Earth's crust was moving, was at the time considered controversial at best and fanciful at worst. Tharp continued to work with the data. The valley kept appearing in the Atlantic. And then, as more data came in other ocean basins too, a continuous system of ridges and rifts running through every ocean like the seams of a baseball, like the slow geological breathing of the planet itself. What Marie Tharp had found, in her years of patient cartographic work, was evidence for plate tectonics. For the idea that the Earth's surface is divided into vast, slowly moving plates that carry the continents with them, pulling apart at some places and colliding at others. An idea that was, at the time, among the most contested in Earth science, and which is now among the most fundamental. In 1977, the same year the hydrothermal vents were discovered, Marie Tharp and Bruce Heezen published a complete physiographic map of the world's ocean floors, a map that showed, for the first time, the full extraordinary landscape of the deep. The mountains and valleys and plains and trenches. The world beneath the water. It was a map of a hidden world, and it changed the way we understood the world we live on. Tharp was awarded the Lamont Doherty Heritage Award in 2001, and after her death in 2006, her contributions began to receive increasing recognition. In recent years, she has been increasingly credited as one of the most important Earth scientists of the 20th century. She spent her career drawing the shape of a place most people would never see, patiently, precisely, turning numbers into landscape, turning depth measurements into mountains. She drew the hidden world into being. Let that settle. The story of the deep ocean is, in many ways, a story about revision. About arriving at a place you thought you understood and finding, upon closer inspection, that it is stranger and richer and more layered than you had realized. This happened most recently, and perhaps most beautifully, in the summer of 2023. A research team led by Dr. Monica Bright of the University of Vienna was working in the Eastern Pacific Ocean aboard the Schmidt Ocean Institute's research vessel Falkor. They were studying hydrothermal vents on the East Pacific Rise, the great underwater mountain range that runs north to south along the floor of the Pacific. This was not unknown territory. Hydrothermal vents had been studied since 1977. The remarkable ecosystems around them had been documented extensively. Scientists felt they had a reasonable understanding of how these systems worked, where the life was, how the communities were organized. And then someone had an idea. What would happen if they lifted a piece of the volcanic crust, not just looked at the surface, but actually turned over the rock and looked underneath? The team used their ROV, their remotely operated vehicle, to do exactly that. They lifted sections of basaltic rock from around the edges of the vents and shone their cameras into the space beneath. What they found there was a community of life that no one had known existed. In caves and tunnels and channels beneath the volcanic rock, in water that was approximately 25 degrees Celsius, warm by deep-sea standards, there were worms. There were snails. There were chemosynthetic bacteria forming mats on the cave walls. An entire community living not beside the vents or above them, but beneath them. Tucked into the earth below the earth. The team described it as a missing link, a connection between the surface of the vents and the rocks below, a hidden corridor through which animals might travel between one vent ecosystem and another, sheltered from predators and from the fluctuations of the vent water above. A whole world nested inside the world they thought they already understood. There is something in this discovery that seems to me deeply resonant with the way the deep ocean works as a metaphor, not just for the external world, but for the internal one. The idea that beneath what is known, beneath the explored and catalogued and understood, there are still hidden places, still worlds within worlds, patient and warm and alive, waiting to be found. In April of 2004, a team led by Jill McDermott of Lehigh University discovered 5 new hydrothermal vent sites in the eastern tropical Pacific. These vents sat at a depth of around 2,550 meters, and they were sending fluids hotter than 300 degrees Celsius up through the seafloor, far beyond the boiling point of water under normal conditions. But the pressure at that depth is so enormous that the water remains liquid regardless. It cannot boil. The physics will not allow it, and so it rises, superheated and mineral-laden, through the volcanic rock, and where it meets the cold seawater, it forms the dark, billowing clouds that earn these structures their common name. Black smokers. They do look, in submersible footage, like chimneys. Like small factories on the ocean floor, pouring dark plumes into the water above. But there are no factories here. No machines, no industry, no human design, just the slow geological processes of a planet, venting heat from its interior through the floor of the sea, building structures that then become homes, become communities, become ecosystems, sustained entirely by the chemistry of the earth itself. It is worth knowing, as you drift towards sleep, that this is happening right now, and around those rising columns of dark, hot water, tube worms are waving their red-tipped plumes, and crabs are picking their way across volcanic rock, and chemosynthetic bacteria are turning chemical energy into life. Right now, while you sleep. We continue softly. The deep ocean has its own acoustic world, and it is stranger and more complex than the silence you might imagine. Sound travels differently in water than in air. Much faster to begin with, roughly 4 times faster and over far greater distances. In the deep ocean, there is a layer at around 1,000 meters where temperature and pressure combine in a particular way to create what oceanographers call the SOFAR channel, which stands for sound fixing and ranging. This channel acts as a kind of natural acoustic waveguide. Sound entering the channel becomes trapped within it, bouncing between the upper and lower layers, and can travel extraordinary distances without dissipating. Blue whales use this channel. Their low-frequency calls, some of the deepest sounds produced by any animal, travel through the SOFAR channel for thousands of kilometers. A blue whale off the coast of one continent can, in theory, be heard by another blue whale on the far side of an ocean basin. They communicate across an expanse of water so vast it takes their calls hours to traverse it. There is something about this that I find very moving, very quietly. The thought of two enormous animals somewhere in the deep blue singing to each other across 1,000 miles of cold, dark water. The song travelling through the Sofar Channel, low and slow, a frequency felt more than heard, arriving hours later in the deep body of another creature who knows what it means. The ocean is not silent. It never has been. It is full of sound, the low rumble of distant earthquakes, the creak of shifting seafloor rock, the chorus of fish and shrimp and cetaceans communicating across the deep. There are sounds in the ocean that have been detected and recorded and remain even now without a confirmed explanation. Researchers at the National Oceanic and Atmospheric Administration have catalogued unusual acoustic signatures from the deep ocean over decades of monitoring. Sounds that don't match any known geological or biological source. Sounds given informal names while their origin continues to be studied and debated. The deep ocean keeps its secrets gently. There is a piece of research that has always stayed with me. Scientists studying the soundscape of the deep ocean before and after major shipping disruptions noted that, during periods when surface vessel traffic was significantly reduced, the acoustic environment of the deep changed measurably. The background noise decreased, and in that relative quiet, the vocalizations of deep-sea animals became more detectable, as if, in the quiet, the ocean began to speak more clearly. As if the ocean, like you, needed a certain stillness in order to be heard. Where's no rush? We have gone very deep tonight. Not in any literal sense, of course. You are still where you were when this began, in a bed or close to one, in the quiet of wherever you are. But something in you may have traveled a little. Something in the mind loosens when it is given permission to drift, when it is pointed not toward a problem or a task or a tomorrow, but toward a vast and ancient thing that has nothing to do with any of that. The deep ocean knows nothing of your to-do list. It has never heard of your worries. It was here before worry was invented, and it will be here, patient and dark and full of slow life, long after. There is a woman called Sylvia Earle, who has spent most of her life in and around the ocean, and who has become, over that time, one of its most passionate advocates. She is sometimes called Her Deepness, a title that began as a gentle joke and became something more like a description of character. She has led more than 100 expeditions. She has lived for weeks at a time in undersea habitats. She has seen things in the deep that most people will only ever read about. She says that the ocean is the life support system of the planet. That without the ocean, there would be no oxygen, no stable climate, no water cycle, no life as we know it. The ocean is not just a feature of the Earth. It is, in a very real sense, the condition that makes the Earth habitable. Its deep waters circulate slowly around the globe in what oceanographers call the thermohaline circulation, a system driven by differences in temperature and salinity that acts like the bloodstream of the planet, distributing heat and nutrients and oxygen across every ocean basin. This circulation takes centuries to complete a single circuit. It is a slow, patient, planetary process, operating on timescales that make human history look like an afternoon. And it affects us all. The deep ocean absorbs heat from the warming atmosphere. It absorbs carbon dioxide. It buffers, with its vast cold mass, the fluctuations that would otherwise make the surface world far less stable than it is. The deep ocean is, in a sense, keeping us calm. It is providing, at a planetary scale, something like the same function that sleep provides at a personal one. A reset. A slow redistribution. A time for things to settle. Breathe. The deep ocean is not a distant thing. It is not separate from you, some remote and irrelevant darkness on the other side of the world. The water in your body was once ocean water. The oxygen in your lungs was produced, more than half of it, by photosynthetic plankton in the surface waters of the sea. The weather that shapes the seasons around you is modulated by the temperature of the ocean, by the slow movement of deep currents that began their journey years or decades or centuries ago in some cold polar sea. You are connected to the deep ocean in ways that are real and biological and chemical and physical, whether or not you have ever seen it. And in a quieter, more metaphorical sense, you share something with it tonight. The deep ocean, in its perpetual dark and cold and stillness, is simply resting. Not inactive, not empty. We have seen that it is far from empty, but profoundly, fundamentally, unhurriedly at rest, doing what it does slowly, in the dark, without urgency, without agenda, without anything needing to be resolved before morning. You can do that too. You may have drifted. That is fine. Robert Ballard, the oceanographer who became famous for finding the Titanic in 1985, said that we know more about the surface of Mars than we do about the bottom of the ocean. He said it to make a point about how much remains unexplored, how much remains to be known. But I think about that statement a little differently sometimes, not as a problem to be solved, but as a comfort. There is still mystery here, on this planet, in this ocean. Right now, as you lie in the dark, the deep ocean is still largely unknown. There are species down there that have never been seen. There are geological features that have never been mapped. There are processes happening in the cold and the dark that science has not yet described. The world is not finished being strange and wonderful. It is not complete. It is still, in its deep and watery heart, full of possibility. And that is true of other things too. Of other kinds of depth, of the depth in people, in relationships, in the quiet work that happens in sleep. You are not empty when you are asleep. You are deep. Just the sound of the words now. The Challenger Deep sits in its trench, as it has for tens of millions of years. The hydrothermal vents send their dark, mineral-rich plumes upward through the cold water. The tube worms wave their red plumes in the warm current. The anglerfish drifts through the midnight zone with its small, cold light. The Greenland shark moves slowly through the dark, unhurried, ancient, patient. Somewhere beneath the Pacific, in a sub-seafloor cave warm with vent heat, a worm the size of your finger is living out its whole life in a tunnel no one had ever seen until 2 years ago. Living quietly, in the hidden warmth, in the world beneath the world. Marie Tharp's maps hang in museum collections now, these beautiful hand-drawn physiographic diagrams showing the contours of a world she helped reveal. The mountains and valleys of the hidden deep rendered in careful lines and gentle shading, the whole vast landscape of the seafloor made visible by the patient work of one person's hands. She drew the deep ocean into the imagination of the world. And now, perhaps, the deep ocean can hold some part of your imagination in return. The ocean covers 71% of this planet. Most of it is cold and dark and ancient and very, very quiet. Quieter than any room you've ever been in, quieter than the space between thoughts, quieter than sleep. Below the reach of any light, in water barely above freezing, the seafloor stretches away in every direction, vast and flat and dusted with the sediment of millions of years of marine snow. The snow still falls slowly through the dark above. It has been falling for a very long time. It will go on falling long after tonight. Let that image settle into you if it wants to. The slow fall. The cold and quiet dark. The vast and patient floor of the world at rest beneath its miles of water. In 2020, a Chinese submersible called Fendouge, which means striver in Mandarin, descended to a depth of 10,909 meters in the Mariana Trench beyond the circle of light. In every direction, the dark continued. The same dark it has always been. Just the dark, just the cold, just the immense and settled quiet. You are allowed that quiet too. There is no urgency here. There never was. Whatever kept you moving today, whatever kept you thinking and planning and worrying and doing, none of it lives down here. None of it reaches this depth. Here, there is only the slow drift of things, the patient continuation, the ancient unhurried presence of the deep. Your body knows how to rest. It has known since before you were born. The same way the deep ocean knows how to hold its stillness, the same way the tube worm knows to wave in the warm current, the same way marine snow knows to fall, you know how to let go. You have done it every night of your life. You are doing it now. Breathe. Breathe. Feel the weight of your body. The way the bed receives you. The way your hands are heavy, your feet are heavy. The muscles in your face are heavy, your eyes. The deep ocean is 3.5 kilometers deep on average, 3.5 kilometers of cold, still, dark water pressing gently down on the ancient floor of the world. There is no season down there, no morning, no evening, no clock, no urgency, only the slow, continuous, patient presence of the deep. You are going there now, down through the first meters where the warmth is still near and the day is still faintly audible. Down through the mesopelagic where the light fades from blue to deep blue to the memory of blue and then to nothing. Down through the midnight zone where bioluminescence makes its own soft constellations in the dark. Down to the floor where everything is still, where the marine snow settles slowly onto the sediment that has been accumulating there for millions of years, where nothing is required of you, where you can simply be the thing you are, quiet and unhurried and deeply, completely at rest. And so we leave it there. Somewhere behind you, the day is already distant. The things you are carrying have settled, the way sediment settles on the floor of the deep sea, slowly, without resistance, finding their place in the quiet. You are deep now. Let the water hold you. Sleep well.